So hello everyone. So in the previous video we have left it out here, right? So let's continue some more things. Let me show you one more thing. Okay, this things were basics, very basics I should say. Let's just not do anything, any of this stuff. Okay, let's just do this here. Let's not do even this. Let's not even include it, increase it. That's not okay. This can be done like either you do this star p, or you can even do your I, and then you'll get the same value. Okay, fine, clear. What if I want to do this? Let's see. Right now, what's happening? What would have happened till here? Till here, basically okay, I has been created, right? I has been created whose values, let's say this address is the address and this is the content. So in my symbol table, let's say this is my symbol table, here i's value has been assigned as, hey, it's kept at 700. I have even created my pointer, okay, p1 is also stored at some address that says 800. So let's say 800, stored at 800 right here. It's stored at 800 p1, and its content is basically the address of I. So why is I 700? So 700 is the content. Okay, great, making sense. So indirectly it's saying that it's containing the address of this specific block. Okay, make sense. Okay, as soon as I'm writing this I, so it's printing me the value. Star p1 means go to the specific location and print whatever the value is. Okay, so again I'm printing the value, no problem. Okay, what if I want to create a queue? Okay, I'm going to create a pointer queue and I'm going to assign it, hey, q equal to p. What does this line do? This line basically means that, hey, star q is basically a pointer. It should contain the address. Whose address? I'm giving what is kept in p, not p's address. I'm not giving p's address. I'm giving what is kept at p. What is kept at p? An address, right? So obviously this is waiting for an address, and it is gonna get address. What is the content of p? 700. So 700. Now see here, one interesting thing happened. Now even q has the address of I. So if I do here star q, we will get the same value 10. Wanna see? Let's see. It's a simple thing, very simple, but let's see. Okay, so this is q actually. Okay, let's see it. So okay, come here and then we'll do it here. See out. Before that, see before see out, let's create even q, right? So int creating a pointers q whose value is basically what is the p? P is basically an address. So I'm saying okay, whatever is value I don't mind, just print the value of star q. What does this star means? It means that, hey, q is pointing to 700. Okay, go to 700, and star means whatever is the value, give me the value, and through the cout I'm saying okay, print the value. Okay, okay, great. Let's see. Okay, before that, what is this? P was not declared, so it's p1. Actually it's not p, it's p1. So effectively I should get 10 printed to line number 12. See, this is basically to line number 5. This is basically to line number where is it, 12. Yeah, and this is to line number 10. Okay, I hope this so not 10, 13. I hope it's making sense. And this is basically to line number 10, not 10, it's 9. Okay, I hope it's making sense. Simple, right? Now what's the thing I would like to tell you guys, obviously since I can do it through for integers, I can even do it for like floats, doubles and all. Okay, making sense, it's fine, we can just do it. Okay, so let me do one more thing. What is that? Hey, what is the size of this specific thing that you're actually saying? Okay, so let's see how we can see the size. We already know how to do the size. Yes, so let's see the size. Generally it's 8 bytes. Let's see what's the size. Before that, let me even check the size of, obviously we know this size of operator, right? Size of give me the size of I is basically a integer, right? So let's not sort the values of I. Okay, let me just do this. See out me the value of whatever is the size of I. What is I? I is basically, so obviously we all know that basically the size is basically 10, right? We know the size is basically 10. So obviously it's not 10, so 4, sorry, it's 4. The size of integer is 4, so we should get a 4 value. Okay, so let's see what's the value. Okay, 4. Okay, generally it's 4, but depends again on the compiler, I should say. Okay, now if I do here something, see out the value of p, size of p1. Okay, what do you think should we get? just clear this up. Okay, yeah, we are gonna get the size, and generally it's actually 8 bytes. Let's see what's actually again what we're gonna get. 8 bytes, but again I'm saying depends on the compiler. Okay, depends on the compiler. So see, every addresses generally contains the size as 8 only. Okay, so if you want to check it, let me actually give one more thing. Let me actually create a double, or let's say float. Okay, so value is, let's say, 5.2, and I can do this star. Okay, star means let's create float pointer fp, whose value is basically the address of, we are not given any value, so let me give here f1. Okay, f1 I should say. So address of f1, I'm gonna be like, okay, see out the value of f1. So I'm not gonna go do the value of f1. I'll be like rather star fp. Obviously this will also give me the value whatever is kept at f1, right? So let's see. F1 was not declared, sorry. It should be float, right? I did two things. And what is here? Cannot convert. Okay, again this is actually a float. See here, basically we're gonna store the address of float, so we need float. Okay, so we should be getting 5.2 as our answer. Let's see what I've given. I've given 5.2. Okay, I hope it's clear, right? Let's see one more thing. Let's do this again, this same part. Okay, control C, control V, but right now I want to see the size of f1, and I want to see the size of fp. See, this is size of f1 and this is size of fp, and this is basically whatever is the content. Okay, see again, even in this case it's basically 8 bytes. So what can you actually assume? You can actually say that, see, whatever may be the type, I don't mind about the type, it's containing an address. So since it's containing address, so the address is basically of 8 bytes. Okay, so either is p1 or fp, both of their sizes are basically 8 bytes. Okay, their sizes are basically 8 bytes. Make sense? Because they're containing addresses. Okay, again I'm saying depends on the compiler. Sometimes, like in case, some cases it can be even 4. Okay, it's fine, but generally it's 8 bytes. Okay, make sense? And we even saw it, right? Okay, so after this part I want to actually say something about pointers. Okay, arithmetic, let's do some operations on pointers. Okay, let's see how we can do and what we should do. Okay, so let's not do this part. Let's just comment this part again. Okay, and star q also just comment it out, it's fine. And what I'm printing, okay, and we can just treat this little star, it's fine. So let's assume that this is only our thing that we need. Okay, focus here. Star p1 basically has the address of I. Okay, and if I can print it, I'll just do c star c out star p1. What if I do this c out p1 is going to give me the address, right? What if I do this, or let's say let's actually store it somewhere. Let's actually again update the value of p1 equal to p1 plus 1, and again printing the value of p1. What actually is happening? Am I printing the content? Am I printing the content? I'm printing wherever this p1 is basically made. Okay, I hope it's making sense. See, star p, sorry, whatever is p1 containing, if you do here address of this p, then this is basically where this p1 p is basically p1 is basically made, right? P means whatever p is basically containing, it's containing the address of I. What is basically p plus 1? I'm increasing the value of p by 1. Okay, let's see what should be the value. Okay, is it gonna increase by 1, or how actually is gonna behave? Okay, that's it. Let's see it properly. So let me explain this part. Let us just come once. Okay, this is basically where it has been kept. It is kept. Okay, this is basically what is the address of I. Okay, so if you want to know, and okay, before that let me show you this one. this is basically the address of p equal to p plus 1. What is this? This is basically, if you see properly, these two are hexa. Okay, these two are in hexa. So once you're doing the operations, if you actually like subtract them, or basically if you add it, if you add here, what is this? This is c. So c basically in hexa is basically this. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, so in hexa actually what happens is, this 10 is basically means a b c d e f. Okay, makes sense. It's c. Okay, it's basically, let's not consider it till it's same, right? So it's c 1c and 2 0. Okay, if you see properly, this is c, it's becoming 0. That means c here, it's c, that means it's 12. So it went first 1 2 3 till d f, and again there is something called 0. Okay, it went to 0. So what added, how many things we added? We added from 1 2 3 4. Okay, we have gone 4 points. So obviously we are adding 4 to this, then we are getting the next address. What does this mean? It means that, see, p was basically pointing to this p1, let's say, okay, whose address is basically I. Okay, okay, pointing to I, whose address is basically 700. Okay, p1 is this. I did p1 plus 1. This means that, hey, whatever is kept at next of I, okay, that means it's saying that, hey, this is integer, so move 4 bytes. Okay, because this, since this is actually an integer, I'm containing the address of an integer. So when you're going to do p1 plus 1, it means that don't add 1 means basically the user is saying that go to the next integer, go to the next integer. So next integer will basically lie at address 4 plus, right? Because if I'm this at 100, let's see, the address is 100, next integer will lie at 104 only, because the size of this integer is 4 bytes, right? So obviously next integer lies at 104. So go to that specific address. That means go to the next integer. Okay, can we do this? Let's see here. Let me show you something. Okay, let me just clear this part. I guess this thing is clear, right? Let's just clear it. We know that this is going to the next integer that's basically adjacent to the I. Okay, so let's see now what's the use of it. Can I do this? And do you think we should do this? Tell me. See, we might get an answer, we might not even get an answer. Okay, I'm telling. Let's see whether we're going to get an answer or not. It depends on where p1 is basically pointing to as of now. Okay, so let's see we're going to get the answer or not. Okay, we're getting an answer. This is basically a garbage value. This is basically a garbage value. Why is this garbage? I is c created, I is created, whose value is 10. That means in my symbol table, I is created whose value is 700. That means the address is 700. So it's 700, 10 is kept here. So and then I'm doing p1. Okay, p1 is, let's say, created 800. So this is p1 created 800 whose value is the address of I. Okay, that's fine. I went and I'm like, okay, do p1 equal to p plus 1, p1 plus 1. So I am telling that go to the next address. See, I is kept here. Let's say, where's I? Okay, okay, I've made I here. So let's see here. I is basically made here. Okay, with content 10 700. Go to 704. Okay, next address. But I should access it. I should not access it, right? Because this is not my memory. This is basically inside my memory. See, this basically this memory is not mine, right? I have the address of only this memory, but I went to this, I came to know about this address by just adding 4. I added 4 through this line. But see, this is actually not my memory, and we don't know what's kept. That's the reason we're getting a garbage value. And we should not even do this, because if we do this, it's like, if in case this is just like read on memory, and if what if I do here after this line, if I do here star p plus plus, that means this will actually increase this value. But this can be a very critical memory, like critical part of like our system, and we are trying to increase that part, so it's very risky. Okay, since this is not your memory, never do it. Okay, let's see if in case we are doing, let's see, let's hope it's not a critical part. So let's see, in case if we're doing, let's see, I've already updated it, I'm printing the value, and after printing the value, I'm like, okay, p1 is pointing to something. Okay, no problem, let's make it, add it by 1. I have no idea what's p. Okay, I have no idea where is p? See, I know p is basically pointing to the next integer that's been kept after I. Okay, but I have no idea what's that. There may be an integer, I have no idea, right? It's basically the next address, right? Next 4 bytes after I. So I'm saying that okay, we go there and you even update the content. Why should I do this? This is very risky, okay? But let's see whether it's getting updated or not. Let's see, and let's even print again the value of p. Okay, okay, so let's even print it. Okay, and let's print it. C, Control C, Control V, Control S, F11. See properly. This is basically the content now. Okay, because after doing p plus 1, and I'm increasing the value by 1. But why should I do this? This should not be done. Okay, right now it allowed me to do, but sometimes it does not allow us. Okay, so never do this. Why should we then? Why are we even studying this? Why are we studying even this? So that we can go to p plus 1, like we can even do p1 minus. Okay, so if you do here, like after this online, if you come here and do here like p1, or let's I have changed the content. Let's not change the content. You can just do this also. P1 is basically equal to p1 minus 1. What does this mean? It means that obviously I'll come back one back, right? I can actually go back one, right? Do you think this will give us an error? Let's see here. It's fine. See out p1. Can you guess me what's the value gonna be? And just guess. Just give a guess. Give me an error. See, this value and this values are same. What is this value? If you see properly, I am printing here at line number 10 the value of p1, and p1 was initially pointing to i's address. So see here, this is i's address. After adding plus 4, I went to p plus 1. Afterwards, again I'm doing p minus 1, and I'm coming back to I. Okay, so I can even go forward, I can even come forward, but it's very risky if I have only one specific integer. Okay, I've given you a hint. I've given a hint. What is the hint? If I have only one integer, then it's very risky, because I don't know, this is not my memory, this is also not my memory. Where can it be very useful? Okay, where can I use this arithmetic? If I have an array, if I have an array, if I have an array, and I know that basically these things are basically in continuous form. Okay, let's see that this address is 700, and this is an integer type of pointer. I'm sure that this is 704, and this is basically index 1. Making sense? I hope it's making sense. So it will make sense only in terms of this specific arrays. Okay, the operations on pointers, okay, will basically make sense only when we use it on arrays, because in array I can be like, okay, get the address of this specific location. Okay, I got the address and make it 1, that's it, and go to the next address, make it 2. So I'm actually trying to do I'm actually doing everything on my array, not here. Like here I was trying to do something here which is not my memory, but as soon as I create this array, this is my memory, right? This is my memory, so I can do it. Obviously I can do it, right? So let's just take this small example, okay, on this array. Let's just take this small example on array. Let's do a small example on it. Okay, I'll just comment this whole thing out. Okay, so now let's take an array of size, let's say 10. Okay, and let's actually go and print the value of a, and let's print the value of address of a of 0. What do you think should be the value? See here, and let me once make one more thing. AR of 0 equal to 10. See out a power of 0 come here. That's what we have done. We have created an array of size 10, 0 1 2 3 4 5 6 7 8 and 9 of until 9 index, right? So I'm doing here, hey, you go at AR of 0 and put it 10 and print the value of AR of 0. So what will be printed, 10 will be printed. What does this A print? A will print, see, I have already discussed that A will point to this array. So A generally points to this address of the first cell. Okay, that's the reason I'm printing here the value of A and printing the address of A of 0 also. So whatever is the address of A of 0 is A of 0, right? So whatever is the address of A of 0, the same address is basically your A's address. Okay, let's check where is the whatever I'm saying is right or not. Okay, it's true or not. Let's just check it. Okay, let's just print it out here. A was not declared. Okay, sorry, it's ARR. It's not A, it's ARR. Okay, see the mistakes. Making errors obviously of always A, so it gets me just confused, but it's fine. If you see the value of 9 and 10 line number will be same. Okay, so what can we deduce from here? We can deduce that we can actually say that hey, whatever is basically the content of A and A0 are basically the same location. Okay, so can I do this? What does this mean? This means that hey, go to this specific location. Okay, you are at A of 0 and dereference it. Dereference means go and get the value of whatever is kept at ARR of ARR of 0 I should say because we are there the same address. So here also I'll be getting 10. That's my answer. Interesting, right? Okay, so you can say that I can go and actually get the value like ARR of 0 also by ARR plus 1. So tell me something, what will be this value? Let me tell you one thing. Let's make ARR of 1 equal to 9. That's it. And I'm gonna do this part. What does this mean? It means that hey, AR is pointing to A of 0. Plus 1 means go to the next integer. So if this is 700, then plus 1 will make it 704. Go there and whatever is kept there, just print it out. Will this print it? This will print me the address, right? This will print me the address obviously. So what I need to do in order to print it? This. What actually happened? Let's run and then see. That will be better. We're expecting 9 as our answer. Okay, we're getting 9. Okay, let's see what actually happened. This ARR plus 1. See, this is basically AR, okay? Sorry, because obviously the name of this array is ARR. So ARR is this. So this is ARR of 0. Great. I'm saying that, okay, you actually first printed the value of ARR of 0. So already we saw that ARR is basically pointing to ARR of 0. So this ARR basically means that, hey, go to this address, go to this specific cell's address and print whatever is kept here. That is print kept here. Okay. Here I'm doing, see, before this star, ARR plus 1. So I'm like, okay, what is ARR? ARR is this. ARR plus 1 is basically this, because I told you as soon as you do plus 1, you will go to the next integer. Okay, you went to the next integer and like, okay, now dereference it. Obviously we know through this line number 7 we have kept here 9. So whatever is kept there, star means whatever is kept there, you give me the value. And what am I doing with the value? Printing the value. So that's the reason we are getting 9 here. Okay, does this make sense? Simple, right? So you understood where should we use the pointers operations. Okay, this is the thing where we should actually use the pointers operations. Okay, making sense? I hope it's making sense, right? Okay, you can do even one more thing. Show you to do that part and then we will see. What if I do this? Okay, I want to create a pointer p. Okay, and let's give the value of ARR. What actually happened? Now this p also has the same address of ARR. And now if I do here this cout star p plus 1, what I'm doing? Anyone? What I'm doing? Through this line, let's go with the starting part. Okay, we know that ARR is pointing to this A of 0. Through this line, I'm saying, hey, p is a point that is also again pointing to this specific address only. Okay, what is the address? This is it, whatever is the address. Let's say this is kept at 700. So inside my p I have 700. So 700 is basically pointing here, saying that hey, I have the content of your cell. I'm doing p plus 1. P plus 1 means this address. We have already seen this one means basically not 1 but the jump of one integer. Okay, jump of one integer means if since your p is basically pointing to an integer, so if you're jumping through to an integer to a next integer, that means you need to move 4 bytes. Okay, so you went to a next integer. Okay, you're like, okay, star means hey, whatever is kept there, you print it out. Print it out. So let's see what's the output. Okay, let's see what's the output, and let's understand it in more detail. 9. How did I get 9? Because before printing these 10 values, I have already kept the values in my p, and I'm printing through my p. Okay, does this make sense to us? Okay, so one more thing I would like to just tell you, one more thing, just a very small thing. Let me just erase this part. Star p, we know that star arr plus 1 is basically giving me the whatever is kept at a of 1, right? We've seen it. So you write either this or you write this, they mean the same thing. Okay, this will basically be converted into exactly this. Okay, this is basically gonna convert into hey 1. So what is this a? So it's actually arr, we can write here arr. Okay, so arr plus 1, it means that hey, go to that specific address, add by 1 the index, okay, and give me the value. Okay, so either you write this or you write this, it's just gonna be the same thing. Okay, just wanted to make clear this part, very simple again. So in order to just prove it, just in order to prove it, I will be like, okay, cout arr of 1. So obviously, the value of arr1 is basically, what is it? It's basically, what I've kept, I have 9, right? Yeah, 9. So obviously even here also on the last 2 lines I'll be getting 9 as my answers. Okay, so let's see. So we are still to do more, a lot of things on arrays. Okay, so just trying to cover the basics on the array. So here we're getting 2 lines. Okay, so as I'm saying, we have like some more things that we need to cover in arrays. Okay, so let's do those things in the next video. Okay, so let's keep till here, like let's keep things to here only in this video. So I hope you understand the basics, right? You are actually getting familiar with the basics, right? How these things are actually working internally. Okay, so in the next videos let's cover some more things. Okay, so see you guys there. Okay, thank you.